Well, good afternoon again. I'm Steve Wilson, and I'm here with Jennifer Wilsey and Cassia Smith, uh, and we're with the Water Survey and the Water Resources Center at the University of Illinois. Um, and this class is supported by RCAP, the Rural Community Assistance Partnership, with funding through US EPA. And so we'll just get started. So today we're going to because there are, I believe, people who haven't participated in our webinars before, we're going to give a quick overview of the class and then go through some logistics and then talk about water quality in your well today, and then at the end we'll have a chance to answer questions. And in theory we're going to have a couple, a geochemist and the director of our lab here for the questions a little later to help with that part of the class. Okay. So the private well class is a series of 10 lessons. They're self-paced. If you've been on the website, privatewellclass.org, and signed up for the lessons, those should be emailed to you. The webinars are in support of those 10 lessons, and again, to give you a chance to ask questions. So the website is really the host resource, and that's where all the information will be provided. And eventually we'll have links to all the resources from the webinars and the classes there as additional information when you have questions down the road. And I'm going to have, oh, there we go. So this is the front page. The webinar, obviously, if you look at the site today, the new webinars are listed over here on the right. If you click on this box to enroll in the class, that's what gets you to the 10 lessons. And we continue to have emails referring to these webinars as the class. And we just want to make everyone aware that it's not the class. They're meant to supplement the class, as I mentioned before. And to get the 10 lessons, one a week, you just need to go to Private Well Class and click on Enroll in Class. And the way this is set up, it's meant to work from the day you sign up. So if you go on the website today and sign up for the class, you'll get a link to a pretest and lesson 1. And then a week from today, you would get lesson 2 and so on through the end of the class. So you're not missing anything. It's not like we've already been through this, so it's too late. Whenever anyone new finds out about the class, they're able to sign up and start then. Okay. When you go to the site to sign up, this is the page you get. One of the things we ask is just for the state you live in or territory. This is an old slide as well, so that we know where folks are participating from. That helps us with our grant as well, and so we appreciate it if you fill all that information out. The 10 lessons I mentioned, they start out basically about the science of groundwater and how groundwater flows, the different well types and the issues related to that, and then we move on to pumping, piping, the infrastructure of your water system, and then best practices. And as we move forward, we'll get into problem solving emergencies, how to find help, and then today's webinar is about really lessons 8, 9 mostly, and a little bit of 10 on groundwater quality and what you can do to protect that groundwater quality at your well. This is again the third webinar, and there's the other 2, and I guess we'll get started. So today's webinar is being recorded. We've had a couple of people ask, the second webinar hasn't been put up on our website yet. That's my fault. And, but we do have it recorded just as we're recording the webinar today, and eventually you can get on privatewellclass.org and click on the webinar link, and it'll give you a YouTube video basically of all 3 of these. And so we have had over 400 people sign up today. I don't think we have that many on, but if when you have a question, if you'd write it down and send it to us in the question box, then at the end we'll put all the questions up on the screen, and we'll take a break before we start that for 5 minutes, and then we'll try to answer those questions. So some important points to remember. We're talking about water quality in your well. Again, private wells are not regulated. That means there's no one making sure that your water is safe to drink but you. And you know, community water supply, they're regulated by the US EPA and the state regulatory agencies, and they're required to meet certain drinking water requirements. The MCLs, you hear that term, they're the Safe Drinking Water Act, regulated chemicals, so arsenic has to be less than 10 parts per billion, for instance, and nitrate less than 10 milligrams per liter, some of those things that you hear about all the time. If a private well comes back with a sample result that has a high value, it's up to you to do something about it. There's no regulation, and on the flip side of that, there's no added protection that way either. So the thing to remember about well water, I grew up on a well, I've mentioned that before. It can be the best tasting, clearest, odorless, the whole 9 yards, but that doesn't mean that it doesn't have anything in it. A lot of things that get into well water or into groundwater may be odorless, colorless, and have no taste. So it's the way to really protect you and your family is always to collect samples and be a good steward of your well, and that's the whole point of our class. So some key points and for water quality and source water protection, really there's 3 pieces that you need to understand. Knowing the natural water quality of the aquifer you're using. So for instance, there are natural occurring contaminants. We mentioned arsenic, uranium. There's other things in groundwater, other metals for instance. If you're in an aquifer that has those, they're there. They're ubiquitous in the aquifer at different levels possibly, but they're a constituent you have to deal with, and a lot of times the only thing you can do if you have natural occurring contaminant is treat for it, because it doesn't matter where you drill in that aquifer, you're likely to find it. The other thing is understanding how your well might be influenced by surface sources, and I'm going to go into these in a little more detail here, and that means that your wellhead's protected, that you keep sources away from your well as far as you can. You know that how vulnerable your well might be based on the geology, the depth of your well, and where the source water for your aquifer comes from. And so that gets back into the early lessons of the class, talking about groundwater flow and well type and well construction issues, and that's the third point. Having a properly constructed well that protects the well at the surface. So if there's a flooding event, or if there's a spill near your well, you know, nothing's going to run down along the casing, for instance, because you've properly constructed the well, or it's been modified to be properly constructed. So natural groundwater quality, the thing you need to do here is investigate what your natural groundwater quality is. You can find stuff online, or you need to go to your water resources or water quality agency that regulate well construction. Those are good places to start. Your county health department may as well know if there's a certain constituent that's found frequently in your area. And the next piece of that is you need to have an idea of whether it's a nuisance contaminant or a health-based contaminant, and ask them to explain what they are if the resource agency can't tell you. And that way you know for sure what you need to test for when you get ready to have a water sample taken in your well. And yeah. So, for instance, this is the Massachusetts Department of Environmental Protection's website. They have a lot of arsenic and uranium in certain parts of the state, and so they've developed a map and also this tool where you can actually just type in your address, and it'll tell you your risk, if you will, or probability of finding arsenic or uranium above what's considered a safe level. And they also have maps for arsenic and uranium, I believe, on this website, but it's an example of how a state has developed resources for their private well owners and communities as well because of the natural contaminants that they have in their area. I show this just because one of the issues is variability. This is Tazewell County, Illinois, which this is a project that Tom Holm from the Water Survey and I completed about 10 years ago. These are arsenic values at a series of homes. The total distance here is less than a half a mile, and it varies from 2.4 ppb, which is below the standard, which is 10, to as much as 82 parts per billion, which is 8 times the standard basically. And over very short distances, a couple hundred feet or less, you can have an order of magnitude difference in arsenic value. And that's just a characteristic of this particular aquifer. There's a lot of homes that are on this aquifer, and when we get calls from both well owners and drillers asking us, can I go deeper in the aquifer or shallower? There's no real rhyme or reason that we've been able to determine. It's just this aquifer has natural arsenic in it, and some places it's higher than others. And so you may be lucky, if you will, and be one of these homes where the arsenic is 2, and you may be unlucky where it's closer to 80, and then you have to make a decision on whether you want to do something about that, and likely you're going to need to add treatment. So protection from surface sources, really this is common sense. The best thing to do is isolate your well as much as possible from any possible source. So if you have a barn where you have livestock, or a feedlot, or you're storing chemicals in your garage, you need to know the groundwater flow direction, so that if water is flowing east to west over your property or under your property, then you want to make sure that you're storing your contaminants on the west end, and your well, if it's possible, should be on the east end, up gradient, so that nothing that might spill and you might not even know about can infiltrate in the ground near your well. And again, this is where these early lessons come in, where we talk about aquifer type and permeability, depth to aquifer. They all influence how much surface contamination risk you really have. So for instance, if you're in an area with sandy soil and you have a shallow well where infiltration's high, then you're more likely to have an issue if there's some kind of spill or surface contamination or that sort of thing. It could also be an issue of maybe you're in a rural subdivision, like the picture I just showed a minute ago with the arsenic example. Maybe your well is up gradient of your septic system, but your neighbor that's up gradient of you has both a well and a septic system as well, and so you need to be aware of what your neighbors are doing as well in order to really protect and understand what your risks might be. Proper well construction, again, shallow dug wells, and again, these webinars are kind of a snapshot of what's in our class materials, and it's covered in much more detail. And so if you aren't taking the class, you really need to have those materials for a resource to really get a better feel for what kind of things you can do and how you might protect your well. But proper well construction, again, if you talk about old hand dug wells or wells in a pit, things where you're risking very shallow infiltration into your well is much more of a risk than if your well's coming from a very deep aquifer, maybe several hundred feet under the ground. This is from Minnesota Department of Health. We showed this this figure in both Lesson 3 and Lesson 8, and so depending on where you're at in the class, or if you haven't started it yet, you might not have seen this, or you may have seen it twice already. But this is just in setback distances that are in their requirements for any new well. But it's a really complete list of all the types of things that might affect your well, and so we've been using it for this class just as a good example of all the things that you need to consider. I actually had someone call me who bought a second house that's across the street from a lake, and their neighbors told them, they're having bacteria issues regularly and that they should just chlorinate regularly. Well, they need to find how that water is getting contaminated and fix the source rather than trying to keep chlorine in their system all the time to do that. So maybe they need to locate their well on higher ground or in a different location on their property further away from those kinds of influences. This is just the bottom half of that same figure. If you're in an area that's more urban, where there may be industry or some of those sorts of things, you need to be aware of what they're doing, and you can talk to your state regulatory agency about if there's any remediation going on in those areas and those sorts of things, just so you know what's going on and what risks you might have. So testing for water quality, I know a lot of people taking this class are probably doing so because of wanting to know more about sampling and testing and what those results might mean. Where do you collect your sample? How do you test? What do you test for? All these questions listed here. So we'll go through some of that today, and again, there's more detail in the lessons. So where do you collect the sample? The water coming out of your kitchen sink could be chemically different from the water at your kitchen. Oh, there's a mistake here. This is supposed to say the water coming out of your kitchen sink could be different than the water coming out of your well. I apologize for that. There are things that can affect your water quality between your well and your house, or in your house. If you have lead pipes, or if you have some kind of treatment, even your softener, that can change the water chemistry between what's coming out of the ground and what actually comes out of your tap. And so, I've mentioned this before, our lab always has people collect more than one sample if they have any kind of treatment or if they have lead pipes, so that we get an idea of the groundwater quality as well as the drinking water quality in your home. Things like if you have lead pipes, a lot of times if you're going to get a glass of water from your tap, you're told to run your water for a while to make sure that you're getting water that's coming directly out of the well instead of that's been sitting in those pipes overnight. And if you have any installed treatment devices, that can affect things as well. So as far as where do you collect your sample and how you do that, you should talk to your local health agency, county health department, and also the lab that you choose to use. We'll be able to provide you detailed instructions on how they'd like to see that done. And so what do you test for? It really depends on where you live and what constituents you have. For instance, we showed that diagram for Massachusetts. There are areas there where you might want to test for arsenic because it's a concern. Your local and state health department and state agencies are the best people to ask for that advice, knowing again the natural water quality for those sorts of things, plus things that are identified in your area. Talk to your neighbors. Co-op Extension may be able to help as well. One thing you should do is test for coliform and nitrate annually, really because they indicate a pathway into your well. And though coliform bacteria itself isn't necessarily going to make anybody sick, it indicates that there's a way for bacteria to get into your well, and it could mean that E. coli or other things are getting in your well that could be harmful. So this is a picture from the Rhode Island Department of Health, and I show it because here's another state that's provided information for well owners. The little dots that are throughout the map here are locations where there are orchards where they used a lot of arsenic in the past, and so they recommend that anybody who might be in one of these small areas should test their well for arsenic from the contamination standpoint, not naturally occurring. And the big splotch in the middle is where they have a high incidence of beryllium. And I can't really tell you the health effects of beryllium, but it is regulated, and it just happens in Rhode Island they have that issue. And so again, your state may be able to provide you with some guidance on some of the constituents you should test for. What we suggest, and this is partly based on, and I don't have the credit here, on several state agencies, which will be in our resources list eventually, but also from our lab here at the Water Survey. You should test annually for coliform bacteria and nitrate, and initially, if you haven't had a water sample tested of your well, which is a lot of people, you should test for all the constituents listed here, mainly to give you a better feel for the water quality you have and whether you might have issues, need a softener or some of those sorts of things, and what issues you might have. pH is important because of corrosive properties of water. If you have lead pipes or copper pipes that have lead solder, corrosive water can cause those things to leach out and create a problem for your drinking water quality. So this is a list of all the standard things. As we go through, this is from the National Groundwater Association's wellowner.org page. You can look at what they list here are reasons to test your water. Some of the common things, if someone's getting sick often, or if you have visitors who get sick when they drink your water, it may mean that you have a bacteria problem. Corrosion in pipes, then you want to test for pH and see if your water's corrosive, and you may need to treat for that. If you have anything nearby, like I mentioned before, a factory or a gas station, you may want to at one time test for VOCs or volatile organic compounds, just to be sure that there isn't a problem with any of that sort of thing. Or if you smell gasoline or something like that, then certainly you want to call your health department and ask them to come out and assist you with that situation. Because a lot of times if there's a problem with gasoline, now if you're in a very remote area, it may be that you have a buried tank you didn't know about, or maybe it is your buried tank. In that case, you need to have that disposed of properly and removed. So there's things that you need to do as a well owner as well to make sure that you're taking care of your property. Okay, so where do I get a sample analyzed? Every state accredits labs that are required that do the required testing for a lot of community water supplies, and you should really try to use one of those labs. And in our lessons, we provide a URL on the US EPA's webpage where they list all the agencies in each state that do that accreditation, and you can find a list then in your area of a lab that you can use that's approved, which means they meet certain standards and they have certain quality control requirements that they meet that that verify that they know what they're doing and the results they provide are accurate. And so there are also states that have private well sampling programs. We used to have one here in Illinois. A well owner could call the State Water Survey and have their water sampled for inorganics and metals for free. Now that program's went away, unfortunately, but there are some states that still have programs under certain conditions where a private well owner can get their well sampled. In Illinois, still through the Public Health Department, if you have a concern or you have some contamination problem with your well, you smell gas, for instance, you can call your health department and they'll come out and take a sample to verify that there's a problem. So as far as getting it analyzed then, once you've picked a lab or you're looking at labs, they should be able to give you the sampling instructions you need, how to preserve or store the sample if that you need to do that, and let you know the best sampling procedures that you have for collection in order to get a sample to them that still viable. For instance, for some things, if a sample gets old, it's more than several days old, it can change the chemistry of the water and it's not valid anymore. What you should really do is ask questions of the lab until you're satisfied with what they tell you, so that you're comfortable that they know what they're doing and they've given you the advice and they'll be able to answer your questions once you've had your water sample. And again, they should also provide the bottles and all the other information you need. You may have to go pick that up. Some may send it to you, but they should be able to answer all of your questions. And if they can't do that, then you probably should find another source or another lab. This is an example of a free program in New Mexico. Their Environment Department has a septic tank program where you're supposed to register your septic tank, and any new septic systems that go in are regulated and they have to be registered. You also have to register your tank at a property sale. So if you sell your property to somebody else, that tank has to be part of the process. There has to be an evaluation to make sure that it's still working properly and some of those things, and that there's forms that have to be filled out. And what they offer in return is free testing for their clients, as they mention here. And so you can get a few things tested for. It's not a real comprehensive test, but they do provide analysis for, it says here, fluoride, iron, and nitrate, and conductivity. And also, if they can, organic vapor, which is a VOC, volatile organic compounds, which would mean gasoline and some of those things that are man-made, mostly substances. So, in New Mexico, there's this kind of option. In your state, there may be some other options. I know in Iowa, there are programs their state has for their county health departments that offer to help or pay for analysis of private well samples as well. So, interpreting your results. You can use websites, and I'll show you some examples and documents that are online. A lot of the co-op extension offices, or through the Wellmaster programs in some of the states, and through the health departments, and even DNR and some of those organizations have information on the basics of how to interpret results. But your best bet is to take your sample to your results to your health department and to get a qualified answer. This is someone who that's their job, is to help you. And if maybe they don't know something about a certain constituent because it's an odd duck or whatever, they'll be able to find that answer for you. And so if you do have something in your well, you should always resample to confirm. Sometimes the lab does make a mistake, or a sample gets contaminated in one way or another, especially a bacterial test. That's very easy if you don't follow all the instructions properly and to introduce some kind of contamination into that sample. So if you've sampled for coliform bacteria then and it's positive, then you should have an E. coli test done, and you should boil your water until you can either chlorinate your well or the test comes back and shows that there's no risk. If you have E. coli, that's the bacteria from human and animal waste, then it's a serious health risk, and so it's nothing to take chances with. I wanted to show this Penn State Extension and the Institute of Energy and Environment has this drinking water interpretation tool, and I think the next slide I provide the URL, and it's really, it's like a first cut. It's a really good way to, you get your result, you're not sure what it means, you can go into this system and everything's in milligrams per liter, or if it's another unit like these microbial results here that are shown, but you can type in a value and it'll tell you what it means. And so at least the standard definition, so to speak, from EPA. And so I typed in arsenic at 0.1 parts per million, which is 1,000 or 100 parts per billion, and it says it doesn't meet the acceptable standard. Now that's the public health standard for a community water supply, but it's really the guide, the MCLs that we mentioned before, and the drinking water standards that are used for community water supplies is really what you should use for your own drinking water supply. That's where EPA is deemed the level of any kind of constituent is safe or not, so to speak. Again, this is a Pennsylvania website, and so it says in Pennsylvania arsenic can originate naturally. It gives you an example of what's going on, and it also has, you can click for more information to get arsenic information. And aluminum, it was 0.1 and the standard's 0.2, so that was fine. And so it's just a really good tool to use. Okay, water treatment. I'm not going to say a lot about water treatment today because it's a really big issue. And lesson 10 of our class will cover a lot more of the information on water treatment. But to try to do that today, I could probably we could probably go on for hours about different kinds of treatment and what they mean and how they're used. And it's really a site-specific issue based on what you have in your water. And in a lot of cases, there are a number of treatment options for any one constituent. And so we're going to try to cover that in a lot more detail in our lesson for the class. And so today, I'm really just going to talk about some of the things that you need to be aware of whenever you consider home treatment. And the best advice we can give you is to make sure you talk to a professional about what your home treatment needs are, especially those you don't need. If you go talk to a manufacturer, and not that they aren't necessarily reputable, but it's a big business, and there are a lot of cases where folks have treatment on their wells or in their homes where it's really not necessary. And so the thing to do is talk to someone who's unbiased and find out exactly what your results mean, what your treatment options are. And I want to mention this Penn State Extension has this great paper. It's called Home Water Treatment in Perspective, and it basically talks about all these issues, the do's and don'ts, why it's such a big business, and how you can avoid expensive treatment that you might not need. And it also has information on unbiased information, like the national NSF is an organization that tests treatment equipment and provides unbiased results on, does it really do its job? Is it, is it cost effective? How often does it need to be maintained or changed? How long does it last? All those sorts of things. And you can find unbiased information that way on the treatment options you might have. And again, you should always go back to your health department or health professional to ask those questions. Getting ahead of myself here. So you should talk to your health department, and if they don't know the correct treatment, they can certainly call someone who can give you the right information. I know sometimes we even get calls, our geochemists and our lab folks get calls from some of the health departments or from other organizations where someone's come to them and said, I had my water tested, I have this issue, and here's what we would recommend they do to treat their well. And the lab that did your analysis, you should be able to call them as a part of their customer service. They should be able to give you suggestions on treatment or find someone who can. And the most important thing you can do is be informed. There's a lot of information out there from unbiased sources, as I mentioned, on the treatment options, understand how that treatment works, what kind of maintenance is required, what the cost alternatives are, and in some cases it may be there's an alternative to treatment. One of the first things you can do, for instance, is try to determine if there's another aquifer, maybe drilling a well into a deeper or even possibly shallower aquifer may change the chemistry. I know in Wisconsin, for instance, they've discovered there's a certain bedrock unit that's at a specific depth that is very high in arsenic, and they've actually changed their state law so that now that unit has to be cut off, so to speak, so that you can't draw water from that unit. You can get water from above or below, but you're not allowed by law to put a new well in that uses water from that particular part of the bedrock because of the arsenic problem. So some common considerations, POU and POE, you heard those terms a lot if you're talking about treatment. Point of use means at the tap being used, so a point of use system like a reverse osmosis unit to remove arsenic that might be on your kitchen tap only treats the water on your kitchen tap. The other option is treatment that's at point of entry, which means either when it enters your house or before it goes into your distribution into the house, so that all the water in the home is treated. And so know what those differences are, especially if you have a type of device that after so much water is run through it has to be changed. You may want to make sure that you use a point of use instead of a point of entry type device, because all that extra water or water that you're using for flushing your toilets doesn't need to be treated. And again, be sure treatment's your only option. It's possible that there are other things that you can do that might solve your problem, and that's where your health department or your state agency or even your regulatory agency for community water supplies can probably help you there. One of the things I've heard from several state agencies as we run through this class is, recommending treatment is a double-edged sword, because a lot of times folks don't maintain the equipment that they have. They forget about it. They don't really understand what the maintenance issues are with that equipment, or it's too expensive, so they let it go. A filter doesn't do you any good if its useful life is over and it needs to be replaced. You need to make sure you can replace that filter, or do whatever maintenance is required if you add treatment to your system. So that went a little quicker than I expected, but we're going to take a 5-minute break. And so hopefully there's been a number of questions, and we will start back up then. I've got almost 20 till 2 Central Time, so let's start back up at 1/4 till. And we have for sure one person from our lab, Dan Webb, who runs our public service lab, is here to help answer questions, and we may have another person joining us as well. So take a 5-minute break, and then we'll try to answer your questions.